that up today. We're just going to go over right now the ignition system. So I'm going to go over the two-stroke ignition system, which I'm just going to pass this around. This is a complete ignition system for a little Outboard. Actually, Yoli, if you remember Yoli, the lady, it was off her old boat, and she was throwing it away, so I just stole everything. So you're going to see the green part, which is your stator. So, can anybody, off the top of your head, what is the purpose of a stator? To produce power, right? Alternating current or DC current? AC current. How am I getting that AC current from what? From the flywheel. Correct. So as the flywheel has magnets and it passes, it creates alternating current. In turn, remember, your engine runs off of DC. So now I have AC current. How does it go to DC? What does it go through?
Rectifier.
So this little nub thing right here is your rectifier. Where the hell is it on here? There's your rectifier. Okay.
It's this one.
That converts it. And also that gives you your tack signal.
It's let me show to you. It's that one. That's the rectifier.
This is the exact schematic of that engine without wiring harness.
That what is it, Danny?
That is your power pack. I'm going to go through this. So now we know that the stator produces. Yeah. No. Pass it. Yeah, pass it around so everybody can see. So now you know that the stator produces power. So if I have a bad stator and I do compression spark check, what am I going to see? Huh?
But
if I'm not producing power, you're going to have no spark. So here's the deal I want you to think about. So if you have no spark or you have some spark. If you have some spark, that means you have power going into the stator, right? But you still start from the source. I gotta keep going. You still start from the source. So if I'm only getting spark, let's say I'm only getting spark on out of the 4-cylinder 3, I really don't need to do a stator output test because I'm getting spark on all the other ones. Because I'm producing the power that it needs. It's just this one's not firing. Okay? So then that's when you start troubleshooting, and I'll get to that next, okay? So now you know that the stator produces power through the flywheel. So if you have a bad flywheel magnet, will that affect your charging and all that? Yeah, it'll affect it because if the magnet, I'll bring a flywheel. I had a flywheel that disappeared, but I'll bring a flywheel from the shop that the magnets came loose. And what happens is those magnets are spaced specifically. So it has the polarity, so as it runs through, it's producing that charge. So if you have a flywheel magnet that comes loose, the engine will run, but it'll run like crap.
Let me tell you something, Danny. Excuse me. The flywheel with the magnets is here, no? And there are magnets in front of each coil. And one magnet is positive, the other one negative, positive, negative, positive, negative, positive, negative. When the flywheel is spinning, positive and negative pass in front of each coil and produce positive and negative, positive and negative. You understand? Each time that a couple of magnets, positive and negative, from the flywheel pass in front of this coil, produce one cycle. 2 cycles, 3 cycles, 4 cycles, yeah, and after that pass for the rectifier and is converted in DC. That's the DC current that enter in the harness. And you have DC for sensors, for spark, yeah? Like Danny said, if one of those magnets fail, because those magnets are glued.
Yeah, they're glued, they're epoxied in. Well, some are epoxied in, and the one that you've seen there is actually molded into the plastic.
So if you have one magnet fail or crack or fall off, right?
The engine will run.
At all?
It will run.
Okay, so would it be the same?
It's going to fluctuate, so the engine's not going to run
So all
properly.
cylinders will fire.
And then if it's a computerized version, it's going to tell you system voltage below expected range. Even though it's running, it'll give you a system voltage below expected range.
It'll be below 55?
Well, on the E-Tech side, yes, below 55. On the other models, it'll be a different number. Ever is the only one that has the 55 volts.
So we're,
When one of the magnets is broken, the symptom is that the current is not continuous, it's intermittent.
I'll get to you in a second. So here's the deal. when usually a flywheel magnet is part of the service. This is why I tell you, when you guys are doing services or you're doing any work on a motor, observation is key. Can't explain to you how key, because you know what? You do a full service on the engine, because here's the problem. A lot of customers think a service is going to solve their problem. Oh, it just needs a service. Doesn't quite work out that way. Okay, so I tell them, yeah, do a service. And if I find anything in the service, then I'll give you an additional estimate as far as what needs to be done. So then I'll do the service, and then I'm looking. I look part of my services. I'm looking at the flywheel. I'm looking for leaks. I'm looking for burnt wires. I'm looking for something that's stiff. Anything that I can bang the customer for money. But not banging them because I want to bang them. I'm banging them because he needs it repaired. But that's money that you're generating for your company or for yourself or for whoever you're working for. So the key is to look at it. So now, on a loose flywheel, do you think it would make a noise? No. Some do, some don't, depending on the magnet. On certain magnets, which I'll bring a flywheel next week. The magnet comes loose, and you'll hear it. It's rubbing. So here's the problem with that. Okay, if you don't resolve that, what happens to that magnet every time it's hit? It's breaking pieces and pieces and pieces. So in turn, it takes out your stator, because if a magnet gets wedged between another magnet and hits this coil, that's it. You just damaged the stator. This is a $400 stator. If you find the problem, all he needs is a $1,000 flywheel. If not, it's a $1,000 flywheel plus the stator and plus the starter, because where's the starter located? Right here, right? So if you got magnets flying around, they start getting stuck inside the starter, and now you have to replace the starter, you have to replace the stator, and you have to replace the flywheel. So now you went from a $1,000 part to now probably $1,500, no more than that, probably $1,600, $1,700 plus your labor. So what could have been like a $1,200 job can now be over a $2,000 job, only because when you were doing the service, you didn't check it out. Now, you can always play it off, oh, it was fine. That's everybody's favorite word. Oh, it was fine before it was working. I didn't see that problem before. And sometimes it does happen. But here's a way you can look at it. If you do the observation and you look at the magnets, you can see corrosion, and you can, and depending on the size of the magnets, you can go underneath the flywheel with your hand and push on the magnets and see if they move. Or you can look here. Okay, there's space here. There's space here, there's space here. Oh, there's a magnet that's touching. Just by looking.
For that reason, it's important during the cranking, you be familiarized with the sound of your engine during the cranking. If someday during the cranking change, it's one magnet free or loose.
Okay.
What about using a mirror to inspect?
You can use mirror, or you can use one of those borescopes, go underneath the flywheel and look at it. Do that.
Since they're like glued in, what would cause that? Too much heat?
No, it's because it's a glue, it's an epoxy.
It's on a steel flywheel. And what happens to steel when it corrodes? It oxidizes and it swells, and the epoxies come off.
Yeah.
Some you can glue the magnets back on. You have to clean it, do a 2-part epoxy. They sell it, and then there's some magnets it's just replaced. Okay. Now, so we understand. Everybody understands the flywheel, the purpose of the stator, right? No question. We understand the purpose of the rectifier, right? So now from the rectifier, it sends the power to your trigger. The trigger is this other piece here. How does the engine know on this particular model? How does the engine know when to fire?
But they use ECU.
There's no ECU on this one. This is a strictly carbureted, old school.
Rotations.
Well, there's rotations, right. In the flywheel, there's an inner magnet. So you have an outer magnet, and you have an inner magnet. And the inner magnet has notches, okay? So as that trigger, as that flywheel passes through, I know you didn't pay attention to it, but you just looked at it because you're just looking at it. But if you look in here, there's little pieces of notches in here to get the signal from the inner magnet. That's how it knows, hey, cylinder 1 needs to fire here. Oh, cylinder 2 needs to fire at 3, 4, or whatever the firing order is. Okay? That's the purpose of the trigger. Okay? Now,
can you repeat that part? But this is the most important part, the trigger.
The trigger, yeah, because the trigger gives the signal to your power pack, which is this blue thing you saw. that's what produces the 40,000 volts to go to the spark plug. So if that trigger's bad, will I get spark? No.
Where is located the trigger, Danny?
Trigger's right underneath the fly, right between. Okay, so if you look at this sits like this, just like that, and you have your throttle. So when you throttle, it advances or retards the engine.
Can you repeat that situation?
This is your stator.
The stator.
The flywheel goes on top. The trigger goes in here, and as you advance the throttle, it tells it when to fire more because you have the inner magnet that's holding onto the crankshaft, and you have the outer magnet, and that signal will tell the trigger when to
this
fire.
This element is free.
This is like your crank position sensor on the new engines. Yeah, that's exactly what it is. Okay, so
there is no sensor reading that; it goes off of the magnet.
Off the magnet. Let me tell you.
The
Robert
accelerator
and I had
turns.
a job that was really the job I should have never took, but sometimes you do stupid things. And I took this job, and this guy was from Miami, and no one could figure his shit out. And I was like, okay, just bring it and we'll do it. The guy spent a lot of money with me, but I spent a lot of time on it. So what happened was that the magnets on the flywheel were bad. We replaced the magnet, getting no spark. We had one engine that had spark and one engine did. So when I confirmed that it was the magnets, I took the flywheel off the other, there was still no spark. What happened was he had a bad trigger, he had a bad power pack. So what tells me, if you have that many bad components at one time, what do you think is possible that would cause that to fail? All of them at the same time. A surge, right? But not a surge from a battery. It's going to be a lightning strike close to the boat. A lightning strike close to the boat will wipe all your electronics from the boat. Sunny Florida, man. Lightning capital of the world. And the problem is the customer doesn't know because he's not next to the boat when the lightning struck. So we had to replace. Oh, and his flywheel inner magnet came loose. Because that inner magnet comes loose, that flywheel's no good. You can't fix that one. The outer magnets you can fix on that particular model, but on the inner magnets, once they go bad, you gotta replace the flywheel.
Excuse me, Danny. In that engine, you have the distributor and the cables per each spark plug. In this engine, you don't have distributor because you have the trigger. No?
And the trigger to the ignition cord. Well, the trigger to the power pack.
Correct. And in the power pack, you have a cable for each spark plug.
Right.
No?
Yeah, this has each terminal here goes to the individual coil. So here's your individual coil. And here's something that everybody makes a mistake. I did it.
This coil receives
the signal right from the power pack. This is your power pack wires, okay?
Correct.
So this sends the voltage that it needs to hear when the trigger tells this to fire. But this component does a lot of things. This turns your engine on, and this turns your engine off. And it has any sensors, like any faults, like any sensor, like overheating, puts you in rev limit. The rev limiter is in this. This is like a little mini computer, but as basic as it comes. Same thing with this one, it's just a different style. This is from an OIS system, but this one here is the typical ever one. And the Mercury has switch boxes, the little switch boxes that I'll have two of them, because that one controls a low speed and a high speed, okay? So going back to this. So if you look at this,
this is two-stroke.
And you're changing this power pack, people make this mistake all the freaking time. One wire orange with a blue stripe, one wire orange, and one wire orange with a green stripe. So who goes on the top? Blue for sky and greens for ground. Remember that. It's the same thing for the trim and tilt. Blue for sky and green for ground. So blue, top, orange is the middle, and the green stripe is the bottom. It's very easy because this thing's tucked away in the motor, and it's not like it's open like this. It's kind of like behind the coils, and this comes like right here. Yeah, obviously we know the blue one ain't gonna go to the bottom one. It's too short. But it's very easy to confuse because those two coils like these are on the top are like right next to each other. So it's very easy to swap. So that's how you pay attention. If you did that, what would happen to the engine when you start it up? It'll fire up, it'll miss, because the firing order's off. It'll run like shit.
So it'll be reversed, right? No, but
No, it won't be
not-
reversed.
No, not
What happens is not firing when it's supposed to, so you're gonna have a serious miss. Because the piston's coming up to dead top center to combust the fuel and air and needs the spark to ignite it. Well, that cylinder now, you put that wire on a different cylinder, so that stroke's at a different point. That's why the trigger has those little marks to know which one to switch.
But the order of the spark, it wouldn't be in reverse if you put the, it would just be.
No. The only time I ever seen a motor run backwards is someone hooked up the battery backwards on a two-stroke. You couldn't do that on a new engine, two-stroke. That doesn't happen very often. How does that work?
You hook up
Well, because they put a positive, the negative, negative, the positive, so it's working in reverse polarity. I've seen engines do that. I've only seen it like twice, but it's been a long time. Because that you could only get away with a system like this. On a computerized system, you blow the computer. Okay, or blow a fuse.
This is an electromechanical system.
Yeah, this is electromechanical. So, all right, so now we know that you have to have a signal that goes to your power pack after the rectifier. And the trigger tells this power pack, okay, now we need to fire in X cylinder, and so it fires. So now we know, now that you know what you know now. Any questions before I go any further, what you know now? Okay, so now you know that this system to this point. So if I had no spark at all, what's the first thing I should do? And forget about what I just said now. What's the first thing you should do? Spark check, right? I got no spark. So after the spark check, what do you do? Okay, but listen. Remember, this power pack grounds it to kill the engine and the starter, right? What I tell you guys about isolating, you have to isolate the boat, right? Okay, here's your engine. Here's your battery switch. Here's your ignition switch. The neutral safety switch. I got no spark. I disconnect the harness, like we're doing here, plug in my harness, boom, engine fires up. So what does that tell you? The problem ain't in the motor. So you were already thinking about troubleshooting the motor. You would have wasted all day trying to figure out what the problem on the motor is when the whole problem's in the boat. You have to isolate. Same thing with a fuel system problem. You're having a problem with fuel delivery. How do I isolate the tank from the boat? Portable fuel tank, right? So if I isolate this and I have spark, then I got a bad ignition switch. Because behind the ignition switch on a two-stroke, not the order, whatever the order is. So you have ignition, battery, magneto, and start. Okay? So here, when you turn on the battery switch, you should have constant power to that ignition switch. Right? So if I turn on the key, what's the next wire that gets power? Ignition. So right now, key on, this should be 12 volts. Right? So when I turn the key over, what's the next wire that gets power? Huh? Starter?
Magneto.
What color wire is that? Yellow with a red stripe. It's your yellow red stripe. So the yellow red stripe will come here. Okay, yellow red stripe. So that when you hold the key over, 12 volts goes here, excites the starter, right? Okay. The key here is ignition. So if you thought it was a problem with the ignition switch, you can go right behind the key switch, your probe tester. Beep. I got 12 volts. I got 12 volts. Key on. I got nothing. Bad ignition switch. That whole spark issue you have over there is because you're not getting power from the ignition switch. So if I disconnect it, which I'm going to tell you something now in a little bit about how you don't even need a key switch on an old system. I'll tell you in a little bit. So if you got no power here, it's not working. So here's another thing. The magnetos is usually a black. Some are black and yellow, some are solid black, black with a white stripe. That's an open circuit when the key's on the on position. When I shut it off, it's a closed circuit. So if that's a ground, that's sending a negative to that power pack to kill the engine. So now that you know that, you're gonna have customers call, hey man, I go to shut the engine off, the damn engine won't shut off. I turn off the key, turn on the key, turn off the key, turn off. Because it's not the ignition switch or the harness is back, right? Because it doesn't ground the system. This is how it grounds the ignition system.
Danny, that's the ignition switch. And what is this?
Which one? These?
No, that one.
This is your ignition switch looking behind the ignition switch.
Ah, okay. In other words, in this type of engines two-stroke, the ignition switch have those 5, 6 terminals.
All outboards pretty much have that.
Oh, okay. That's
All
clear?
outboards. Even the 4-strokes have that as well. It's just more computerized instead of being the old.
Can we repeat the name of the terminals? One is battery.
One's going to be battery. Now there's one that's purple with a white stripe. That's your choke. On a Mercury, it's a yellow with a black stripe. It's a choke. This one chokes. So when you push the key in, you're choking it. You're supplying fuel to the choke solenoid to shoot fuel into the cylinder to help you start the engine up when it's cold. The 2 M's are your magnetos. That is what grounds your system out. This doesn't have to work in a sense that to start the engine up, or it could be faulty and be grounded. It should be an open circuit. Your ignition is your key on. This is what supplies power to your gauges, supply power to the power pack, because the power pack is going to have power, but it won't know when to fire until the engine's running.
So normally it's when the 2 magnetos when it's normally open.
It's normally open with the key
circuit.
on.
But when you have the key on, it closes.
When you turn off the key,
When you turn it on,
it breaks the circuit.
it breaks the circuit.
Yeah, because what it does is it shorts this out and kills the engine. Okay? Most outboards on the purple wire going into them have some kind of fusible link, so you got to check the fusible link too. Okay, that protects the system if some damage. So you have so now we know if you broke the system and you fire it up on the engine works, the problem is here. You just have to know where to start. The whole key to everything here is to know where to start. Where am I going to start looking? Where am I going to start troubleshooting? Problem in the motor or the problem in the boat? Understand? So let me explain something else, because I've seen this in the past. You could have a shorted out gauge grounding out this ignition system. So what should I do to verify that it's not a bad gauge? Disconnect the wire. Because this wire only gets power when you have the key on. So you disconnect the wire, yeah, I got the 12 volts. So something's shorting it out. So it could be a gauge, because this ignition supplies power to the gauges, right? And that has a ground, right? So if you have a shorted out gauges, it's going to short out my ignition system. So if I have no voltage, because sometimes you put a voltmeter and it shows negative, but then as soon as you disconnect the wire, I have positive again, a gauge can cause that same problem. That's why it's so important. Problem on the boat or problem on the motor? So okay, so let's say we have a problem on the motor. So now understanding the circuitry says, okay, well I got no spark. First thing I should do is what? Check what's the main, what supplies power to everything? Stator. When the engine's turning over, right? So you do a stator peak output test. You can do it. The manual says resistance and both. The problem is resistance is affected with temperature. If it's super hot outside or it's super cold outside, the resistance is different. So peak output test is my favorite. Okay, so I use a CD77 or DVA meter, and you turn the engine over, and according to the manual, some will say between 150 to 175, or if it's a newer style engine, it'll say 20. It'll tell you at X RPMs. It'll tell you this voltage, 20 VAC, whatever the voltage the manual says. So if I have that, then I know it's good. So I got peak output voltage. Then you go to the next one. The rectifier, and this is physically burnt, but if you look at the rectifier, your wires here that produces the AC current is your yellow wires coming from the stator.
Okay, that's important. The
This
yellow
is-
wires are coming from the
and these
stator.
are signal wires. Okay?
The yellow wires are neutral and ground.
Yeah. Neutral and
Excuse
ground.
me, hot and neutral.
Hot and neutral. So this will supply, this is where you do your check. and then every motor's different. Okay, so because some don't have stators,
How much voltage
have
AC?
an alternator on that other engine, right? So you got to know what you're working on. We're talking about the stator. We're going to go into the alternator, because the alternating system is the same thing what you learn in diesel. You need an exciter wire to produce the voltage. That you should already know. But as far as this, this is different. Because even though this is a Suzuki 4-stroke, and this is what the new 4-strokes look like, it's just an older version, it has a stator, it doesn't have an alternator. But yet you go to that Optimax or you go to that 4-stroke Mercury, and it has an alternator. So it depends on what you're working on. So, go ahead.
Yeah, I have a question. So, according to what you said, the stator provides the
Power to everything.
power to everything and to the coils as well, right?
Right, because
But-
this takes this power
yeah,
and
but
converts it.
how are you gonna spin the engines and test the coils if this provides the sparks?
Oh, you have to turn the engine over.
Oh, and
Yeah, when you're doing the test,
okay,
you got to turn the engine over and
And
see it's
after.
producing voltage. So
And
if
after
I had this
disconnect.
flywheel, I would put my, see you have a terminal on this particular one, which is like the one you have here, has a little terminal block, right? See the yellow wire?
yeah.
So
Okay,
I
now
would
I
put
see.
my meter here,
Okay, I see.
turn the engine over, and see what the voltage is.
What? How much is the voltage?
On this one here, I think it's like 150 to 175 VAC.
AC.
150.
AC. 150.
Depending on every motor's different. On this particular one, about 150.
Okay.
Somewhere less, okay? So I got no spark. I do the first thing is like I told you guys from an electrical class. Always go to the source first. Do I have a dead battery? If the engine's turning over fast, obviously you don't have a dead battery. But you have to go to the source. This is where it supplies your power to everything. So that's the first thing. Not only missing one spark, I'm not gonna do a stator output test because I'm getting power to everything else. If this wasn't producing no power, I would have no spark. So let me explain something to you. You have to know the system you're working on. Because on the old EFIs, the Mercury EFIs, there was a yellow wire for each ignition coil. They would go to each ignition coil. So if you have no spark on one, you have to do a stator outputs on all 6 wires. This one only has 2, but that one has 6 wires. You have to do a stator output and you'll find the problem. So again, service manuals are so important. I don't care how much I know. I have plenty of service manuals because I do not care to remember every single detail of what specs are. Generics, hands-on, I have the experience, and obviously the same motor I work on, I'm not gonna need the manual. You should always have the manual. I have a manual, a huge manual. I have a lot of manuals because I don't care to remember that stuff. Oh, if I'm rebuilding a motor, I don't want to remember the torque specs. You think I'm going to remember the torque specs for every different engine that I work on? No. That's why we have service manuals. Service manual is a reference. If you have a doubt, you go to service manual, you look at it, you have a question, how you're going to do it. Okay, read the information. That's what like if I'm going to do something that's been kicking my butt, I'll usually take the service manual home and just kind of read up on it, do some research on it, just to have an idea or get a game plan on how I'm going to attack this. All right? So you do a stator output test and it checks out. What's the next thing you check? Trying to keep the sequence in your head. What's that? There you go, the trigger. Now this trigger doesn't have a output test. Basically what it is a resistance test. So how to do a resistance test. So whatever the resistance test, if that passes.
What is the
next?
symptom when the trigger is faulty?
The trigger giving you no spark. Or it won't advance the timing. So the advance of the timing is not an electrical defect. It's a mechanical defect. Because what happens on that trigger, you see how there's a groove right here? There's a piece that holds, because this has to move. The flywheel moves constantly. The stator doesn't move, it's stationary, but yet to advance the timing, this has to move. So what happens is, on these stators, you see this epoxy? See how it's all shiny? When these stators start going bad, it gets hot, and then the epoxy melts, and the epoxy falls on top of the trigger. And then the trigger, what happens is, once you're done using the boat, what happens to the epoxy? freezes up. So the guy will call me, say, oh man, the motor starts right up, but I got no power. So knowing what you know now, one of the easiest way to test that is what? Disconnect the cable, move it by hand. Oh, that's your problem. I had a customer tell me that that was off of TPS, but same principle. Man, I started up, I got it, and then when I do put in neutral, it went in neutral, but man, it was revving too high because the timing wasn't going back to its place. So you have to have free movement on that, especially these carburetor ones. They have to be free of movement, because if it binds, it'll keep your RPMs up, or it won't let your RPMs advance. So that's two things you know. No spark could be a trigger, or no advancing. How would I check to know if it's advancing or not? Besides, let's just say it is moving. How would I know if it's really advancing or not? What would you use? Timing light. You put that at the number 1 cylinder. You put it on the flywheel. You're looking at it. You're turning the engine. You advance the throttle. You should see advance and retard. If it doesn't do that, then there's a problem also with the trigger. So there's 3 different things you can have problems with the trigger. Remember, I keep telling you, you can have one symptom with 3 different problems. Okay? So now, you check that. Okay, well, the stator checked out good. Then you gotta check the power pack. You gotta follow the manual procedure to check the power pack. So, let's say I have only spark. I have spark on all cylinders but 1. On this particular model. How would I be able to diagnose it quickly without fucking breaking every meter and every tool? If I have no spark on this cylinder, what's a quick way I can check it?
Check the outboard power pack.
Well, hopefully these leads, hopefully it's not this one and this one. It's this one and this one. I could swap the lead only for spark purposes. I could put this one, this lead on this one and this lead on that one, and see if the problem moves. If the problem doesn't move, what does that tell you?
The problem's in
It's on the coil. Because you just swap this lead, put here, you have no spark here, you have spark here. I move this here, I have spark. It's the coil. The reason I tell you that, because here, you gotta undo bolts. Like I said, hopefully it's right next to each other. It happens. If it's just one, try to get it to whichever's close. You have a bolt here, 7/16. So you have this like this. So instead of taking the 2 screws out, take the 2 screws out of that one, put this one to this one. 2 seconds, you can know that answer without even breaking a tool out. Maybe needle nose, because if I got fat fingers like me, you're not gonna fit it in the spot that you need to do that. Now, if the problem moves, what does that tell you? So I had no spark here, and all I did was swap the leads, and now I have no spark here, but I have spark here. What does that tell you? Power pack. How easy that was, right? It's not rocket science. It's just understanding it, and someone like us can explain to you the easy way, because that they don't tell you that in the manual. That's not in the manual. The manual tells you, break out your meter, do a bench test. That's a lot of time. It's okay to do it in the beginning because you've never done it, just to get the experience on it. But when time to me is money, and I'm gonna go troubleshoot it. Oh, I got no spark here. I got spark in every cylinder. All right, let me just swap this. Oh, spark moved. The spark didn't move. Bad coil. And if you wanted to verify it, it's just 100%. You put it back the way it is, and you move that coil, and the problem moves, and you verify the coil. But usually, if you swap that wire to here, and still have no spark here, it's bad coil. Now, talking about the coils. Coils have little grounding. This particular one, and most of them do as well. They have these groundings, okay? Look how dirty that is. I've seen worse. This is not so bad. So you have to check your grounds. Because your number 1 electrical problems on most things is going to be a grounding issue. So you got to check the grounds. Oh man, this is like caked up, or the terminal's all like literally just rotted up. Take it apart. Even though you have no spark there, you take it out. If you have to replace the terminal. Get some sandpaper, clean it, put it back in, test it. Oh, I got spark now. So it was just a bad connection. Or I still have no spark. Bad coil.
This is the ground.
Yeah, that's the
What about the small terminal?
This is your signal.
Signal
From here.
From here.
And
Okay.
this is your output for the spark plug wire.
For the spark plug. It's clear, my friends? That the signal, what color is normally that cable?
It's always going to be, on this particular model, it'll be orange.
Orange.
Orange, green is down, the bottom one.
And
orange
that signal is coming from the
from
coil
the
pack
power pack and from the trigger. Yeah.
and from the
Some only
trigger.
have one.
Well, that one has two. That's a 2-cylinder.
Okay, this one is because the engine is
And this one's different. This one actually has a specific ground wire. See, it's a different system.
okay.
This is one system, and that's another system. This is an old system.
Okay, the orange enter here directly, and you have only the output for the spark plug.
Correct.
Yeah, it's clear, my friends?
Okay? So, yeah.
For the coil on the top, and then the gray box right there. What is that gray box? Power pack?
This one here, that's your power pack. That's this, or that blue one on that harness that you saw. Because you can have an individual power pack for each bank of cylinders. It's a 6-cylinder or a 4-cylinder. I got 3 for this one, or 2 for that one, or 3 for this one, 2 for that one. I got no spark on this side. I got spark on that side. What can I do really easily without breaking out a meter? Swap the power packs. They don't tell you that in the book. They want you to measure and test. It's okay. But working alongside with someone like us that had the experience, we already know we don't need to break out the meter. Okay? So then you swap the power pack and the problem moves. Okay? You got a problem with the power pack. When the problem doesn't move, now you got to check the trigger and the stator. Okay? Even though the stator is producing power, because in that power pack, on that stator you have 2 individual leads. This has 1 lead that feeds 1 power pack. Okay? All right. I only have spark on one side of the cylinders. It's a 4-cylinder. I got spark on this side, but no spark on that side. Swap the power pack, same thing. What could affect that besides being a bad power? Well, I'm sorry. You take this power pack and it works on the other side. So you know the power pack's good, but I still have no power coming out of that power pack when it's on that side. What are the possibilities that could be? Trigger, we just talked about that. Possible stator. What else? Neutral safety switch. No, the shift interrupt switch, my bad. All right, there's a difference between shift interrupt switch and neutral safety switch. Neutral safety switch doesn't allow you to start a gear. Shift interrupt switch kills the engine for a split second. So what happens is...
Oh, excuse me.
I brought one.
The neutral safety switch interrupt what cable? Neutral safety switch. Excuse me? Interrupt neutral. Neutral is to avoid start the engine if the engine is engaged. What cable I need interrupt to avoid a start? Yellow, red. And the other one on the control interrupt what cable? In the control you interrupt, in the handle, you interrupt the purple. And the neutral safety switch interrupt the yellow, red. That's the difference, okay? Don't forget that.
Well, anyway, I had it. I showed you, and I don't know what I did with it now.
Which one?
The shift interrupt switch. Not the shift interrupt. So the interest will kill a bank